Hello, welcome to Smart Learning. In this video, we will be discussing about parallel combination of resistors. In previous video, we have talked about resistors and their series combination. You can check that video by clicking on that I button, or I have provided the link in the description. Right now, let's capture the topic of this video. Parallel combination of two resistors. Let's consider two resistors R1 and R2. We have to connect these two resistors in parallel combination. For this, first end of these two resistors are connected to each other and similar to the second ends. And from common point of both ends, we extend the connection and connect to the voltage source B. Current I is flowing through the circuit, and from that red dot, current is divided into two parts, I1 and I2, where I1 flows through resistor R1 and I2 flows through resistor R2. These two currents combine to give I at other common point of R1 and R2. In parallel combination of resistors, current is divided but voltage remains same across the resistors. Req is equivalent resistance of R1 and R2 here. So I is equal to I1 plus I2. But we know that voltage V is equal to current times resistance, that is I into R. So replacing current I by voltage and resistance, we get B by Req is equal to B by R1 plus B by R2. BV cancels out. So 1 by Req is equal to 1 by R1 plus 1 by R2. And finally, R equivalent Req is equal to R1 R2 by R1 plus R2. This gives equivalent resistance of R1 and R2 combined in parallel combination. This circuit containing Req is equivalent to the circuit containing R1 and R2 in parallel we just showed you in the previous slide. Now let's consider three resistors R1, R2 and R3. We have to connect these three resistors in parallel. You can see on the screen these resistors are connected to single voltage source having voltage V. Current I flows through the circuit, and at this point current I is divided into I1, I2 and I3. So since the resistance are in parallel combination, so total current I is equal to I1 plus I2 plus I3. So V by Req is equal to V by R1 plus V by R2 plus V by R3. And again B cancels out, so we get 1 by Req is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And rearranging this expression, we get Req is equal to R1 plus R1 times R2 times R3 divided by what we get here is last two resistors R1 R2 R3 plus first two R1 R2 and R1 R3, sum of these three products. Now if there are n resistors having different resistance values, then R eq is equal to 1 by R1 plus 1 by R2 plus 1 by Rn. So writing this long expression in short form, we get summation I takes value 1 to n 1 by Ri. We have n resistors. If the resistors are identical, that is, they all have same resistance, then equivalence resistance of n identical resistors is 1 by R eq is equal to 1 by R plus 1 by R n times. And simplifying this, we get 1 by R eq is equal to 1 plus 1 plus 1 n times by R. Finally, we get equivalent resistance R eq is equal to R by n. This is in parallel, but in series combination, for an identical resistor, we get R eq is equal to n times R. So you can see the difference. Let's consider an example where R1 is equal to 3 ohm and R2 is 6 ohm. But we need 2 ohm resistance. How can we use these two resistors? For this, we can combine them in parallel combination. This is 2 ohm and this is 6 ohm resistance. So R equivalence is equal to R1 R2 by R1 plus R2, and putting the value of R1 and R2, we get R eq is equal to 2 ohm, which is less than 3. So R eq is less than 3 ohm, that is minimum resistance in the circuit. Another example, R1 is equal to 100 ohm and R2 is 100 ohm again, but we need only 50 ohm resistance. How can we get 50 ohm from these two resistors? Simple, we have to connect them in parallel combination so that Req is equal to 50 ohm. So from these examples you see that parallel combination of resistors decreases the value of resistance. This much in this video. We will see you in next video with some new topic. Till then, stay connected with us.